where is Electra used? The fields of use for Electra, we are basically targeting all the overhead power and distribution lines operators. So basically electricity power line distributors, telecommunications, cable distributors, all the municipalities which deal with the distribution of any kind of communication lines. But not only overhead, Electra can also be used for the underground power and distribution lines. So there is the functionality there to design the underground cables as well. The supported CAD platforms are BricsCAD and all the AutoCAD verticals. Especially, let's say, AutoCAD Map 3D offers some extra functionality which will also be shown in the video later on. The first important thing is the supported standards. What we have implemented in are the Senelec standards, those mentioned here from the 2009 and 2012 versions. The 2012 also defines the wind loads, and that standards are different for specific countries. So what we would like to ask you partners is to check those standards and provide us. We will basically email you what is needed to implement in the Electra. Currently we have in the Slovenian standard. There is of course the possibility for user to edit it, but we would like to implement those parameters in the local installations as well. Electra comes with a digital terrain modeling because of its support for the basically BricsCAD and plain AutoCAD and map softwares where there's no digital terrain modeling tool. So CGS DTM is already part of Electra, so that user can create any terrain from any ASCII file containing north, easting and Z values. Okay, here is one part that was mentioned before. So if users are using map or other GIS functionalities, Electra works very well with it. You know, so you can display the parcel information, the existing infrastructure information. So here is some underground existing infrastructure, so that the design can be, let's say, more precise and more accurate, and also in terms of where all the conditions are. So which parcels are available for you to design, where are existing infrastructure, basically, let's say, starting points or the connection to existing infrastructure and where to end it, etc. As you can see here in part, when we define the alignment or the power line, we can define its parameters, okay, its name, and we can also define to which surface it will be automatically projected, so that the creation of profile views is dynamic and automatic. But also the wind parameters can be specified for each power line. So there are the wind zones defined for each country, and also land category values for each country, and those two values are of our interest to implement in Electra, so that we can conform to each country's values, let's say, from the beginning. As user just install Electra and they have all the values implemented in correctly. Electra enables, those are some comparison to the old Electra as well. So in previous version there was only one conductor possible to be attached to the poles. Electra now provides the ability to add as many conductors to poles as user needs to, and define all the loads, the wind loads as presented, and all other parameters. Any changes, if created or made to the profile line, are represented dynamically in the profile view. So if user is just changing the layout of the profile the profile automatically updates, and that's a significant improve in our software. Next thing is there are different tools to check safety distance analysis, especially the safety distance between the lowest conductor and the terrain line. Users have all the possibilities to dimension heights, distances, slopes, etc., and make their own annotations. Okay. Another great tool in Electra is, as mentioned, the analysis of crossings. And here we can see the crossings between two power lines, and user is now able to check whether the vertical distance from the uppermost cable and the lowest cable of the two power lines are apart for the amount that's needed, let's say, and that analysis can be done based on different loads, different wind loads, parameters, etc. What's also important is that user can check the crossings towards other infrastructures like rail and road, where a needed usually 6 meter distance between the conductor and the upper point of any infrastructure is needed. Okay, and the last and let's say the most important thing is the production of conductor SAC reports, where basically all the conductor parameters are listed. So which cable was used, what's the span for that conductor, what's the base temperature used, critical temperature, minimal SAC, the calculation span, the load factor, the total catenary length, and all the sags from -20 to 40 degrees Celsius, so that users have the, let's say, all the preview of the sag for different conditions. The sag reports is made in an external ASCII file, where basically all conductors designed in the drawing are listed. Okay, so here we've prepared a short video just to show you the functionality. So as mentioned, Electra comes in a CGS infrastructure suite, so it's a part of all of other softwares. So we have there the menu and the ribbon possibilities. We just start a new project, and here I've prepared one terrain just to show you how this digital terrain modeling tool can be used. It's just here an example. So we will create a new surface, and I will use an external file which has an X, Y, and Z data. Just click OK. So select that contours will be presented, click OK, and in a matter of a second or two, the terrain is created. So we will now move back to the ground, which I've created before. So we have here an underlaying of an existing infrastructure, and we also use some map functionality to show all the parcels, so all the land, and we are now just zooming in a part where we'll do the design of a new power line. So we will start an access manager, and here we can start from an existing power line listed, or just create a new power line, basically new axis. This functionality is very similar to, to Platea, Ferrovia, Aquaterra, so you should be quite familiar with it. So we have other possibilities here to define description, starting, stationing, etc. And now we run the command to draw the power line. As you can see here, we have power line selected. If we have more surfaces, we can define to which surface the automatic drape will be created. Now we will just zoom in and start from, let's say, from this point where an existing infrastructure has ended, and we will now design this power line with an angle. So there will be two sections of this power line. And as you can see in the layout preview, there are already some poles created at the beginning, at the angle, and at the end of the power line. We go to the profile view draw, and when we click in, so like this, we get the preview of those poles already. So the beginning pole, the pole at every angle of the power line and at the end are already predefined, but can be edited. So user can change their height and other parameters. Also, if you can see, when we change the layout, the profile view updates automatically, and that's a significant improvement towards our software possibilities. So we will now define a conductor. So here we selected the first pole, the first tension pole, and on it we will now attach a cable. So there is a list of cables in an external XML file, which can be also edited, so users are able to add their own cables, especially some optical cables which are now very let's say, modern and quite used, so can be added in. So we have now defined the cable, we defined the height of that cable, and that cable is now attached to the span between two tension poles. And here, because there's a slope, the cable is always above the ground, but we will create, let's say, put another cable in the second section of the span, of the power line span, and you can see here that the cable basically interferes with the ground. So we need to add some extra poles here. We will just change from the tension pole to the support pole, and we will now add those poles into the drawing. So the insertion of the poles can be interactive, as you can see, just by clicking that button. User can go in the profile view and click the location of the pole. Let's put in 2 more. So you can also see that the preview of the SEC is always available, so user has some information whether or where to put that pole, and also the stationing can be set specifically, let's say, to as needed. What is important here is the possibility to edit poles. Okay, we can edit the pole parameters and also their position. We can change the position in the profile view, as you can see here. And let's say for this example, we will just change the height of that pole from 10 meters to 11 meters. But what's sometimes even more important is the possibility to change the location of the pole in the layout. As you can see here, let's say this support pole has been put just on the edge of between 2 parcels, and maybe there is no right to put it there. So the designer has to move it, whether forward or backwards, to get to the proper piece of land where they will be able to put that pole. Okay? And the preview of those moves, if you were looking accurately, has been automatically previewed in the profile view. Okay, here we'll show the possibility to add more conductors to that power line span. So we always select the first tension pole on which we attach cables. We define some technical parameters for the cables, and then we have to define the attaching point. So basically the height at which the cable will be attached to the pole. So here we have now 2 cables added to this span section. And in the bottom you can see that here is the conductor's height and the poles attaching point heights represented, and bear in mind those values below. So we will now add additional pole, and the height of those bands is limited now, and as we add a third conductor here, we'll put it on 8 meters on OK. so the bands are automatically updated, and also the height of those bands is automatically updated. So no need for users to edit those bands manually, adapt the heights, etc. So everything is basically done on the fly. Okay, so what we'll do here is make those safety height checks. So we can define for this lowest conductor whether it meets the 6 meters safety height toward the terrain, and as we can see here, that is met. But we can also check the safety height between two conductors, and we are interested between the uppermost conductor and the middle one, and here we will set a 0.9 meters of height. And when we go into the drawing, the red line presents that safety height, and we can see here that it interferes with the middle cable. So we have to change something, either physical data of the uppermost cable or lower the middle cable, etc. So what user can also do is label those safety heights. So we are just clicking points in the profile, and you can see in the bottom window that the safety heights are labeled in the band for safety heights, and we can also label those safety heights for, let's say, for a specific interval in profiles at some terrain points, etc. What's also important is the creation of a seg report file. We just export that report to an external ELE file, which we can just represent here. We will just open it. It's basically an ASCII file, so let's see it here, with all the data that users need. So what is basically important is that the seg calculation is common in every country. What differs is only the loads parameters that can be assigned to the conductors, and that's an input value that needs to be done in the beginning.